All right, guys, I think we're going to kick it off. We're just about at 2 o'clock. Is everyone able to hear me okay? All right, perfect. Well, we're covering secrets. There we go. We're covering our Secrets Manager topic on hybrid workloads. My name is Kevin Higgins. I'm a Principal Cloud Architect with AWS. This is my colleague. I'll let him introduce himself.
Hey everyone, my name is Parimal. I'm a senior engineer with the Secrets Manager team.
So for this session today, what to expect? We're basically going to review builder patterns from 3 common scenarios. Whether you're running hybrid workloads because you have applications with on-premise dependencies or even multi-cloud type deployments, you can still rely on AWS Secrets Manager to basically deliver your secrets across all these platforms. We're going to show you how to create, manage, and rotate your secrets within Secrets Manager, regardless of where you consume those secrets and where the actual corresponding resources live. So we'll also share patterns to synchronize externally, for example, with on-premise secret stores, and then that'll help you achieve better performance and, of course, higher reliability. So that'll be the general topic and focus for today's discussion. So when we think about secrets, AWS Secrets Manager, one thing we like to reinforce is that it is your central store for AWS hybrid and cloud-native workloads. It could even be your multi-cloud secrets hub. We talk about secrets about anything that provides access to your applications, platforms, services. These include API keys, database passwords, keys for certificates, credentials, OAuth tokens, etc. Consuming a secret, obviously, as you all probably are aware, it involves that application or service connecting to a corresponding secret store and then consuming that secret from that source of truth. Oftentimes, of course, secrets are a critical dependency to your application. So you have to plan ahead for reliability, scale, monitoring, and compliance, as this is often a tier 0 dependency for many of your workloads. So in today's world, obviously protecting your data, one of the most critical jobs for any type of a security expert. Applications use secrets to provide vital components of access control, especially in cases where applications are going to provide rights to business critical services or systems. From a DevOps perspective, of course, the challenge that is often commonly faced is managing these secrets. They want to avoid hard coding, and rightfully so, and they also need the ability to distribute and manage the encryption of these secrets. It's a process that can be cumbersome as workloads grow, especially when you have multiple platforms in scope here. And oftentimes, as your hybrid workloads scale, you're going to need to support more communication between machine identities, all of which, for example, must authenticate to one another in a very secure and encrypted manner. So similarly, the growing adoption often that we use here is containers. Increasing number of applications are being moved to containerized platforms. This increase requires that you have to restrict access, of course, and govern the lifecycle of these credentials that are going to be managed between these services. And there's a potential, obviously, for secrets in use to go into what's referred to as secret sprawl, which is a process that will become increasingly more challenging to manage if it's not dealt with and managed in an efficient manner up front. So as a result, many organizations obviously vault their secrets using secrets management or similar type solutions. Instead of hard coding credentials within the applications themselves, you make calls to services such as Secrets Manager via APIs to retrieve credentials whenever they're needed. Trust, of course, is brokered so that secrets can be exchanged, ensuring that only your trusted applications and scripts can request privileged access when necessary. Proper auditing, monitoring, and controls are built in with these types of solutions. So this moves us on to consuming AWS managed secrets from on-premises. This is a topic we're going to kind of hit a couple points on, but first and foremost, the reality is it's no different than any other resource as if it was running within your account, within your AWS, local VPC. You'd obtain IAM credentials. Now that could be via access keys, roles, which can be obtained through a couple different methods. We're going to dive deep into that in the next slide. Once you have those credentials, you can effectively call into Secrets Manager via the API. Permission policies can be applied, which controls which users or services, of course, have access to the target secrets. You can attach it via a resource policy or permissions policy on the IAM entity that you're using to make that authenticated call. for a quick, IAM terminology, the identity-based policy, that'll specify which secrets that user or entity can access. And again, that's applied to the calling resource, whether it is a user or role. And then you also have your resource-based policies, which are applied directly to the secrets themselves. And that can control access based on a number of different entities. Oftentimes it's used for cross-account scenarios as well. So one thing to consider though typically is yet when you're invoking these APIs, there are limits, especially around rate quotas. So for Secrets Manager APIs, read APIs have higher TPS limits than of course our control plane APIs. They're less frequently called, so that's primarily one of the reasons. But you have describe secret, get secret values that have combined limits of 5,000 per second. So as a result, we support client-side caching libraries to help improve secrets availability and of course resource costs. It helps reduce the impact of network availability issues should they arise. You also help to reduce response times and possible latency that could occur. So our cache policy by default, it's least recently used. So when the cache, we look at it from a standpoint of a 1 hour time frame, which can be adjusted, and it will discard the least recently used secret. And that of course will refresh every hour. It is configurable, which you could actually add or change those parameters relatively easily. And again, that actually provides you that additional layer of protection and at least reduce calls to the actual service, especially when you're dealing with a high number of applications. Again, step 3, kind of as we went into that, that's effectively the idea of using the caching component in addition, again, to help optimize costs. So for connectivity, Secrets Manager, obviously the APIs do run on the public internet. For those of you who are familiar, we do have Private Link, and that is a service that you can tie in with Secrets Manager. And this enables you to privately access the Secrets Manager APIs without having to go across to the AWS public network. Oftentimes, customers have secrets that cannot be publicly accessible for compliance and regulatory reasons. So as a way to kind of isolate that public access, you can enable Secrets Manager VPC endpoints. This allows you to access these without an internet gateway. You don't need a NAT device, VPN, Direct Connect, all of that is, those requirements are removed with the use of this Private Link technology. Once that's in place, you could even access these from on-prem as indicated here. So with the ability to establish a Direct Connect or even a VPN type connection, you can transverse the private connection, making the private call to our Secrets Manager service. This is for workloads really in any location as long as there's connectivity to the actual ENIs which are stood up as a result of the creation of these Private Link resources. So connectivity is always a big challenge here. That's what we've kind of gone through some options. But the other thing is that authenticating. When you have resources that are not residing within AWS, you need a way to authenticate those API calls. Everything has to be SIG-v4 signed, so if it's not, it will effectively deny that request. More common than not is customers will do long-term access keys. This is a process that we try to recommend customers move away from, primarily because there's no rotation capability natively that's built in. Once those account keys IAM access keys are created, they are active until they're manually terminated or rotated. There's also no cross-account support, and your authentication is all handled by a single static file that has those keys in an unencrypted format on your local resource. So they're not exactly protected. Yes, they're encrypted when the calls are made and everything is encrypted in transit, but the underlying access key pair is in clear text on that actual resource that's making that call. So moving forward, we've developed a couple other solutions to help address this challenge. One of them is our Systems Manager hybrid activation. Now, for any of you that have used Systems Manager, it's a great tool and is often obviously used to manage AWS resources. We have an extension to that where it allows you to effectively assign a role in the same way to an on-premise resource. This requires, of course, installing the SSM agent on-prem, and you receive an activation code that will then effectively import that resource as a managed entity for Systems Manager. So at that point, you can basically assign a role in the same way that you would do as if it was a EC2 resource or equivalent resource within your VPC. Once you do that, it will assign credentials and manage the lifecycle of those credentials. And that rotates every 30 minutes by default. So all of that is handled by the service itself. They are stored on the actual system in the locations as we've outlined here. But again, those files are ephemeral, and those credentials are ephemeral, in nature. So they will rotate on that schedule, and that is actually a configurable time frame as well if for some reason you want it to rotate more frequently. This brings us to one of our recent launches, IAM Roles Anywhere. For this service, it works very similar. Essentially, it's a credential distribution service. It extends the simplicity and flexibility of cloud services to applications that are not natively running within AWS. It creates, distributes, and rotates those credentials automatically, effectively allowing you to attach the same IAM policies and roles that you could do with native AWS applications. It eliminates the need to manage those long-term credentials as well. As you can see, it rotates every 60 minutes by default, and that's a configurable TTL as well that can be done. This, again, overall, it helps improve the security posture because you are moving away from the risk that is commonly associated with those long-term credentials. The experience of using it is basically like anything else outside of AWS, identical to the roles that you would use with Systems Manager. How does it exactly work? It relies on public key infrastructure to establish a relationship, or trust rather, between your AWS account and your certificate authority that issues certificates to your on-premise workloads, for example. You basically exchange an X509 certificate for those temporary credentials, and then they're delivered directly via the SDK to the application code that requests it. One thing I do like to point out is that credential storage is not necessarily in scope, and what I mean by that is that we do not persist them to disk when you use IAM Roles Anywhere. So unlike with Systems Manager, where it is stored to the credentials file locally, in this scenario, it actually is all received through a standard JSON format when that calling process initiates that request to its target resource, and those are not persisted or cached to disk. So basically, your on-premise applications can call the AWS APIs without having to worry how that access is managed. You can also add additional security controls with this, such as restricting where IAM Roles Anywhere can be used. So for example, corporate IP address ranges, you can specify that as a conditional element so that even if you had a valid certificate, if it doesn't match the correct source IP, you wouldn't actually be able to exchange credentials. If you don't have, obviously, or operate a PKI, which is a common scenario for some smaller businesses, you can use our certificate manager, which is our private CA service, and that'll help create a managed PKI, and that'll allow you to use the IAM Roles Anywhere functionality. Again, key point here is we want to just stress that this helps avoid the undifferentiated heavy lifting of using open source solutions or managing keys in your standard format that is more commonly used for legacy type workloads, et cetera. You can still operate your commercial third-party secrets manager solutions, but with the connection process being managed by a framework that has a lower risk factor and, of course, a higher security element built in to help audit and regulatory compliances. So just a quick recap of how the actual solution works. After the validation succeeds, like I had mentioned, you're basically makes a call to our STS endpoints, and you are issued credentials. And those credentials will work in the exact same fashion when you make all of your calls to AWS or any of our corresponding APIs. The actual process of obtaining those credentials, again, is based on that presence of that certificate. Those certificates can be revoked at any point. If for some reason there is a security incident, you can revoke that, invalidate the certificate, also terminate the role session credentials that were issued. That can be done at the role level, so anyone that was using that role would also lose access at that point, but there is a mechanism in place to control and immediately correct access issues or governance controls if necessary. I'm going to hand it over to my colleague who actually is going to walk us through how the rotation process works when using Secrets Manager for on-premise resources. So, go ahead.
All right. Hey, everyone. So now that we know how we can consume secrets on premises that are stored in Secrets Manager, we're going to do sort of a deeper dive into how you can rotate secrets that are attached to a resource that is on premises. So quick poll with, just raise your hands. How many of you have actually used the rotation feature for Secrets Manager? So let's say about 50%. So that's good. For the rest of you who don't know how rotation works, the way Secrets Manager rotates AWS resources is we launch a Lambda in your account, in your VPC, and the Lambda basically has connections open to your database or whatever resource it is that the secret is attached to. And it's also able to connect to Secrets Manager, right? And so the Lambda sort of handles the code that rotates the resource and the secret. The sort of key thing to remember when we talk about rotating resources that are on premises is that at a high level, it sort of works the same way. So there's three sort of steps that we're going to go through, similar to how you consume a secret on premises. The first one is you have to establish connectivity. And so remember how I said that the Lambda is able to connect to the resource when you're rotating a secret that is attached to an AWS resource. It's kind of the same way with an on-premises resource. Your Lambda has to be able to connect to whatever it is that is on premises. So if it's a database that you're running on premises, then it needs to have a, the networking needs to work, and Lambda needs to be able to connect, log into the database. Like Kevin mentioned, this could be something like direct connect to your on-premises network, or if it's a publicly accessible endpoint, for example, if you're using Twitter and you want to rotate the API key, then that's on the public internet. Your Lambda needs to be able to reach out to the public internet. The second is to customize your rotation function. So Secrets Manager vends rotation templates, and these are for all the common relational databases that AWS runs. If you're running any of those flavors in your on-premises network, then you need to slightly tweak the way the secret is created, but the templates are basically ready. If it's not a database type, if it's a different type of resource, then we publish a generic template with the high-level steps that go into rotation, and we'll talk about that a little further ahead. But basically, you can use that generic template and then customize it to whatever resource it is that you want to rotate. And then the third step is, business as usual. You enable rotation through either the console or the API. You can use the CLI, although the one that we recommend you use mostly is CloudFormation, so that you keep track of your configuration in code, right? So this is a 300 level course, right? And this is where it gets really technical and we dive into how rotation works. At this point, if you've followed the 3 steps that we talked about, you basically have a setup that looks something like this. On the right, you have the application, which could be on premises, it could be in AWS, it could be anywhere really. And what it's doing is it's calling getSecretValue, which is an API for Secrets Manager, and it gets back the secret. Mostly this is the AWS current, which is the latest or the current version. You have the Secrets Manager service, and you can see it's storing this AWS current version. Let's say it's just a credential pair, UAPA, right? And whenever the application calls getSecretValue, by default, it gets the AWS current version. So the first thing that happens is rotation gets kicked off. And the way that this happens is either something calls the rotate secret API, or this is a scheduled rotation, which means you've previously configured rotation, and this is just one in a series of rotations. So the first thing that happens when rotation gets kicked off is Secrets Manager invokes your rotation Lambda, and the rotation Lambda in turn creates a new version of the secret within Secrets Manager. So we'll call this version B, username B, password B. When this version is created, it's labeled with AWS pending. So at this point, your application is still calling getSecretValue, it's still getting the current version. This is still the credential pair that works with your resource. Let's say the resource in this case is a SQL instance running on premises, right? So at this point, your application's calling getSecretValue, you're getting the current version, you're using that to log into your on-premises database, everything works great. It's just that we've created a new version that we're going to use. The second step is when Secrets Manager invokes the Lambda again, it does so with a set secret step. With this step, the Lambda then reaches out to the database or whatever resource and manually sets the password or updates the password to be the version that we previously created, which is password B. Once you've created a password, you need to verify that it works. And so the next step is test secret. All the Lambda does in this step is tries to establish a connection to your resource, the SQL instance, using the newly set password. And in the fourth and final step, we actually go back to Secrets Manager. Well, the Lambda reaches back into Secrets Manager and updates the labels on both the versions. So the previous one is labeled AWS previous instead of AWS current now, and the new one gets shifted to AWS current. At this point, your application is still calling getSecretValue. It's still getting the current version, which is now the latest one. And we've verified, the Lambda has verified that this new version can be used to log into your resource in step 3. And so that's sort of how the process works. We are dealing with distributed systems here, distributed networks here, and so things will go wrong, things can go wrong. Secrets Manager has built-in retries at this point. So for each of these steps, we retry with exponential backoff a number of times, and we restart at whatever step it is that failed. And so this is an asynchronous process, but we do back off and retry. And Secrets Manager then unburdens you from having to do all of that, manage all of that. The other thing that I'm sure a lot of you have noticed is between step 2 and step 4, there can be a slight gap, right? So you set a secret or you set the password in the SQL instance, and then when your application calls getSecretValue, it's still getting the one that's labeled AWS current. So we're basically at this point, right? Step 4 hasn't happened yet. And if your application calls getSecretValue, then it's going to get the previous sort of version. There are a couple of ways of dealing with this, and the way that we recommend you deal with this sort of scenario is you use something that we call a two-user strategy for rotation. The way that two-user rotation works is, suppose your compliance needs or your organizational needs are to rotate a secret in 90 days. Then we recommend that you basically do the half-life, do 45 days, and you use 2 users. And we have rotation templates published, like I said, to open source that do this. The way that it works is Secrets Manager's Lambda creates a clone user of your database user, and it basically clones or tries to clone everything that your original user has. So the same access, the same permissions, right? And we only rotate one of those users at a time. And so basically every 45 days, we're alternating between the users that we're rotating. And in this way, when your application calls getSecretValue, whether it's getting AWS previous or it's getting AWS pending, which is the newer one, it's always going to be a user in the database whose password is not being rotated at that point, right? And so even though you're rotating twice as much, both those users are only getting rotated every 90 days. So with that, one more way that you could deal with the availability sort of risk with single user rotations is we also open source a JDBC connection pooling library. And so what that does is it establishes connections to your database using the JDBC, and it caches those connections, right? So even though on the back end the password might be changing, your connections are still cached, and so your application sort of shielded for a short time from the password changing. Right. So let's dive into how setting up a rotation for your on-premises resource looks when you're using the console. So when you go and create a new secret, this is the sort of first step that you'll run into. At that point, you're selecting the third option, which is credentials for other database, since it's not an RDS or an Amazon-owned resource. You enter your username, password, and then you select the encryption key, which is a KMS key that you use to encrypt the secret. In our example right now, we're just using the default KMS key. And then and then below that, you select one of the supported database types. So in our example, we were using MS SQL, and so that's what we have. And then at the bottom, you have the server address, the database name, and the port, which is what the rotation Lambda is going to later use in order to connect into your database. The next step is to just configure your secret, secret name, description, tags. We've seen people use hierarchical names and tags, especially to manage a large number of secrets across, if you have a large number of accounts, large number of secrets, how do you keep track of them? How do you manage them? We've seen customers mostly use hierarchical names and tags to do that. And then this is sort of where the magic happens. You turn on rotation with the slider at the top, and then you schedule how often you want rotation to happen. There's a couple of ways to schedule rotation. You could use a rate, which is a duration in days and how often you want the rotation to happen. And this, by default, starts at midnight UTC. You can give it an optional window duration, so it'll only try to rotate within that window, those many hours. And then when it retries in case of failures, it'll make sure to stick within that time period. So you can use that in cases where you have cyclical patterns in your traffic. For example, you see more traffic during the day than at night, then you could rotate within the first 2 hours of the day or something. The other way you could schedule rotation is by using cron expressions, which gives you much finer-grained control over your window duration, right? And then at the bottom there, you select the lambda rotation function that you want to use. So in our case, this would be step number 2 that we use to customize our rotation lambda. So that's what the circle is, the customized rotation lambda. So if you want to follow along on your phone, this is like a good way to scan the QR code and see the open source library that I'm talking about. It'll take you to that link over there. And in my screenshot, I've zoomed in on the piece of code that actually connects into the database. So let's dive into that a little bit. So you can see how it just is using a MySQL library to log into a database, right? And it's using parameters that we previously stored in the secret. So previously, we put like the database name, the username, the password, all the connection info that you need to connect into your on-premises database. And so the key part that I really want to highlight is this is really no different than how you would rotate something that was on in an AWS resource, right? So it's basically just configuring the network right and getting the permissions right for the rotation lambda to be able to reach your on-premises resource. And with that, I'm going to hand it back to Kevin.
So again, going back to the hybrid type concept here, consuming these externally managed secrets in AWS requires a couple different approaches that you could take. We're going to run through a few of them and just kind of go back to looking at it from a availability perspective. What's the benefits? What are the drawbacks? These are, again, common approaches we've seen customers take, one of which is creating that parallel set of secrets. So essentially, you have your on-premise secrets for your on-premise application and workloads, and then you have your cloud secrets, AWS native secrets for your AWS native applications. This, of course, is a approach that could work, but there's some challenges that are going to be involved in here. And mainly, as we've highlighted, is secret sprawl. You have the possibility where now that you have applications and services consuming secrets from different locations, you introduce the risk of the possibility of unwarranted distribution or, I should say, an ungoverned distribution of these secrets because you have multiple systems that are managing it. As a result, tracking the secrets become harder, especially with no asset inventory control for it, or really true auditing, centralized auditing for access into these critical repositories. So each time that secret enters into another point, again, that's something you have to think about from an attacker perspective, is that's another point of entry to obtain information that could be otherwise critical or detrimental to infrastructure if it were to be breached. So secrets, again, often corners on your app ecosystem, something that you always want to try to avoid. Because this approach doesn't really have centralized control, there's obviously an increased challenge to manage and distribute it as your infrastructure grows. Also, again, just managing the fact that rotating these secrets when you don't have a single source of truth will require some type of a mechanism in place to ensure that you have distribution and replication in place. And as you're seeing here, replication doesn't exist in this illustration because this is a scenario where, again, HashiCorp or CyberArk is on-prem in your key store. You're not natively replicating it, you're basically just creating two independent repositories that is managed through some third-party governance or even developers. But again, those definitely create some challenges that we like to avoid. Another option again is moving into a scenario where the application's hosted in AWS will actually make a call to your on-premise key store. This approach again does work well in that it does keep everything centralized. The problem is of course you've created a dependency on the network approach. While it does require these applications to make these calls and they can be cached, of course that does require application level code to accomplish that. If for some reason there is a dependency on that network end, which likely there would be, whether direct connect or VPN, you've put in a single point of failure for a critical component of your application fleet. So with the lack, there's a lack of integration with third-party components in this scenario, such as identity or container platforms. Also more advanced enterprise-grade applications with a lot of different components and integration points will require have a much higher degree of secrets that are going to be needed to protect. As a result, you lose the native integration with access control and secrets retrieval as well, because again, we're not using AWS-centric components in this design. We're basically just establishing a network path, ensuring that API call can be successful, but all other components are going to be dependent on the original key store that's located in this scenario on-premise. This brings us to our last approach here that, again, just to kind of illustrate what we would like to see and what more commonly is done in customer scenarios here. This is where we actually have synchronization of secrets from on-premise. So effectively what you're doing is you're caching a read-only copy of an externally managed secrets. Basically, you get the best of both worlds. You have easy management, established centralized system, but caching the secrets in a cloud-native way so that these services can operate independently without being blocked or slowed down by any dependencies with the data center. So by centralizing those secrets and introducing, of course, the proper access controls, which you can do natively with Secrets Manager, you're allowing then to be accessed via the existing tooling that you have in place. You also, again, can strengthen your security posture for your cloud-native resources as well. When we look at this design, typically we are looking at it from the standpoint that all changes will happen in one single location. So for on-prem key store, for example, that's where all updates would occur across all environments, and then Secrets Manager would be able to ingest those updates, or rather replicate those updates via the Lambda function that you're seeing illustrated. Effectively, what would occur here is that the life cycles of your secrets, as they're consumed through various methods, you wouldn't have to rewrite any of your legacy application components or really any components that make your traditional calls to your key store. Instead, when we're introducing hybrid workloads, specifically cloud-based workloads, you still have all of those secrets and also any other components required available to you. But again, we're not relying on any type of mechanism for real-time API calls. All of this will be cached and replicated, so you have that additional availability if and when there's ever a network concern with your existing dependencies on-premise. It also allows you, of course, to audit the secrets centrally for resources in the cloud, third-party services, as well as on-premise. The way we're illustrating it here is obviously with a RAID cron job expression triggered with the event bridge. We do have sample code, again, which is actually on the same GitHub site just to give you an idea of how that Lambda function would play out. Definitely something to look into, but again, we just want to illustrate that these are opportunities, not inclusive of all scenarios, but this is definitely a go-forward strategy for customers that still want to manage a key store in the traditional sense, or any other third-party key store that they use. So I'm just going to run through it again, how this actually works. This is a continuation, of course, on what we were just seeing as a cached read-only copy. Inventory and access control, the idea here is that you determine any secrets that you do need to consume in AWS, and you create those depending, again, of course, on audit control and access components that can all be configured at the actual secret resource level. The idea, again, of determining which ones you need to consume, you could just do a full replication, but ideally you just want to bring in the actual secrets that would be needed. Again, just a tighter security posture there. So you would, of course, create the initial secret with the appropriate controls. In the console, this can be done with CloudFormation APIs or SDKs, and of course, make sure metadata that is necessary is also applied to that. This could also be done in a bulk operation. Depending on your on-prem key store, of course, there's certain APIs that you can leverage and replicate all of that data in. Once that is in place, you effectively would use that Lambda function, and that would be invoked via CloudWatch to pull these secrets from on-prem in either a cron or event infrastructure type fashion, which the trigger itself, again, something that we can configure and dependent upon how to set it up within your environment. Effectively what it does is the Lambda function would read the secrets from your local secret store, and then it would compare with the response metadata. So essentially it's a diff operation. If the secret requires updating, that function then would pull that updated data and then write that to the actual secret within Secrets Manager. Of course, the majority of invocations are going to be no ops. Unless there's an update, I wouldn't actually perform any changes within the Secrets Manager service itself. And as to how often you want to invoke that process, or if you want to have it triggered via step functions or any number of mechanisms to trigger that invocation of that function, there's various options to consider with that. And then again, last one, step 3 is pretty much business as usual. You still have the same auditing and monitoring capabilities. And again, all of this available via Security Hub for auditing purposes, for also looking at sensitive, any type of sensitive secrets. You could have alerting for when they're read. All of those same control sets that are available as if AWS Secrets Manager was your primary secret store. So just along some of the final thoughts here, the creation, monitoring, and deletion of secrets, obviously, these are approaches that you need to consider as your workloads scale, primarily just to have a mechanism in place that allows cross-platform support and also scalability for workloads as they continue to become more modernized and cloud native. You need to consider introducing a structured approach to the creation, use, and management of all of these secret components, and that can of course be done using a cloud native and vault solution like AWS Secrets Manager. It can still be done using your traditional on-prem key stores. Using Secrets Manager, again, could result in greater benefits for AWS cloud resources, no question, but we also want to highlight that the integration with other third-party solutions works very well, and with regards to how the secrets are consumed, although it is an AWS product, it really can be consumed across any cloud provider or any on-prem data center resource. It's primarily a flexible solution that we're trying to build and continue to iterate on to allow you to manage that entire life cycle of all of your secrets, but give it to the point, or allow for scalability beyond our cloud workloads barriers. And hopefully some of the illustrations that we put through, at least on the connectivity end, help show how that can be accomplished. The biggest challenge is, of course, again, authentication of these actual critical stores. And AWS obviously has a couple of new solutions, which is certainly something, if you haven't used it, again, go back, look at IAM Roles Anywhere, look at Systems Manager Hybrid workload capability to leverage and actually bring this into your environments. The ease of the adoption and just the actual service itself and integration is fairly straightforward, and we have it very well documented. Also, again, encouraging you to look at our GitHub repos for sample code sets that help highlight some of the things that we have discussed here. Just on the recent launches end, we do have multi-region secret capability. So again, for DR scenarios, you can basically have all of this data replicated automatically. It still is updated in a single point, but then it is automatically replicated to all of your target regions. We also did launch integration for a secrets and configuration provider. It's a plugin for Kubernetes workloads. This will allow your Kubernetes pods to receive secrets from Secrets Manager without the need for any custom code. It basically ensures your applications are always receiving the most recent versions of your secrets, and as they're rotated as well, it ensures that those pods are updated accordingly. We also increased the secret limit. It was originally 40,000 secrets, and now we're up to 500 per account. We also support rotation windows, so that actually allows you to do rotations within specific times. So for maintenance, or you don't have to actually you don't actually have to do it on a particular schedule that has to be defined. You can basically set it in accordance with defined maintenance windows for all other activities within that account. SSL, again, that was also another integration support that we have, which is built in natively for all RDS type rotation scenarios. We also have the CloudWatch metrics capability being published into CloudWatch now as well. So you can use that to retrieve the number of secrets in your account. You can review how many secrets have been called. You can set alarms for an unexpected increase or decrease in API calls, or just what is stored in the account. Was there anything else you wanted to add with regards to launches?
No, I think you covered it.
Okay. We're also excited to partner with CyberArk. CyberArk actually is releasing a solution very similar to what we illustrated with caching secrets within AWS. A lot of the concepts and the ideas that we put forth are being built into a managed framework that CyberArk is demoing. If you have time on Wednesday, they have a session there. They also have a booth here, as if you want to go over and have an interactive demo and kind of learn how that process could work for your environment. We do have a Secrets Manager workshop that actually was earlier today, but it is published. If you wanted to run through that, that kind of goes through some of the concepts that we've discussed here. Allows you to work within a real environment on our event engine, so gives you, hands-on experience from that perspective. We have our data protection and privacy kiosk. You can ask the experts. We have people there to help you, or if you have any challenges, anything you wanted to walk through on an architecture scenario, we're also there to provide support. And that's about covers the content for us. If you have any questions, feel free to come up. We're happy to address them. Hopefully it was informative to you guys, and if you have anything that you need, just please let us know. Thank you.
We also have stickers up front if you guys are interested.